Have you ever wondered what the future holds for technology and how AI is playing a pivotal role? Well, let me tell you, the world of technology is no longer a realm of what-ifs and maybes. It's rapidly evolving, and at the heart of this revolution is something you've probably heard of: artificial intelligence, or AI. AI is more than just a buzzword. It's a science, a tool, and above all, it's a game changer. It's altering the way we live, work, and even how we think. From voice assistants that make our lives easier to complex algorithms that predict market trends, AI is everywhere. But today we're going to focus on a particular subset of AI, an area that's causing ripples throughout industries worldwide. This is the intriguing world of machine learning. It's where computers learn from experience just like humans, but with an efficiency and accuracy we could only dream of. So sit back as we delve into the fascinating world of artificial intelligence and its offspring, machine learning. To comprehend machine learning, we need to first understand its parent, artificial intelligence. Artificial intelligence, or AI, is the field of computer science that focuses on creating machines that can mimic human intelligence. This idea isn't a new one. In fact, the concept of machines capable of thinking like humans dates back to the ancient Greeks, who told stories of mechanical men designed to mimic our own behavior. Fast forward to the mid-20th century, when the term artificial intelligence was coined at the Dartmouth Conference, sparking a new era of innovation and discovery. The goal? To create a machine that could carry out tasks requiring human intelligence, such as learning, understanding language, recognizing patterns, problem-solving, and decision-making. AI has seen a meteoric rise since then. It's now everywhere, from our smartphones to our homes, workplaces, and beyond. It's in our search engines, powering our online recommendations, helping doctors diagnose diseases, and even enabling autonomous vehicles to navigate our roads. Over the decades, we've witnessed key milestones that have shaped the AI landscape. In the late 90s, IBM's Deep Blue defeated world chess champion Garry Kasparov, marking a significant moment in AI history. More recently, Google's AI program, AlphaGo, made headlines by mastering the ancient game of Go, a feat previously thought impossible for a machine. These achievements are testament to the remarkable advancements in AI. But it's important to remember that AI is not just about replicating human intelligence. It's also about augmenting our capabilities, taking over mundane tasks, and providing us with tools to make better decisions. So, what's next for AI? It continues to evolve, pushing the boundaries of what machines can do. From natural language processing to computer vision, AI is revolutionizing countless industries, transforming our lives in ways we could have never imagined. With this foundation, we can now explore the fascinating subset of AI that is machine learning. Machine learning, a term coined in 1959, is a transformative aspect of artificial intelligence. It's like a child growing up. This child, however, doesn't learn from experiences or school, but from a vast amount of data provided to it. The more data it consumes, the better it gets at making predictions or decisions without being explicitly programmed to perform that task. So what is this all about? Imagine a machine that learns to identify a cat from a dog. You don't write a million rules for it to understand the differences. Instead, you feed it with thousands of images of cats and dogs. The machine then trains itself by identifying patterns and features like the shape of the ears, the size of the body, and so on. This is the essence of machine learning, the capacity of a machine to improve its performance based on previous results. Now, let's take a step deeper. Machine learning heavily relies on two important elements: data and algorithms. Think of data as the fuel for our machine. It's the raw material that the machine uses to learn and improve. Images, texts, numbers, you name it. The more diverse and extensive the data, the better the machine can learn. On the other hand, algorithms are the engine of our machine. They're sets of rules or instructions that guide the machine on how to learn from the data. Different algorithms work better for different tasks. For instance, one algorithm might be better at predicting stock prices, while another might excel at identifying spam emails. And this is where the magic happens. When a machine is fed the right data using the right algorithm, it can uncover patterns and insights that would be almost impossible for a human to detect. Machine learning is indeed a powerful tool, but as with any tool, it's not about how advanced it is, but how we use it. It's being applied in various fields, from predicting weather patterns to improving medical diagnoses, and even in making our online shopping experience more personalized. Now that we've grasped the basics, let's explore the different types of machine learning. Machine learning isn't a one-size-fits-all concept. It comes in various forms. Each form has its unique approach to learning from data and making predictions or decisions. Let's delve into these different phases of machine learning: supervised, unsupervised, and reinforcement learning. First, supervised learning. Imagine a child learning shapes. They're shown a square and told, "This is a square." After several instances, they can identify a square even in a new set of shapes. This is essentially how supervised learning works. It's trained on labeled data where the desired output is known. For instance, email spam filters use supervised learning. They're trained with emails labeled as spam or not spam, enabling the filter to identify spam emails in the future. Next, unsupervised learning. Going back to the child example, suppose they're given a mixed set of shapes without any labels. They might start grouping them based on similarities, all the round objects together, all the square ones together, and so on. This is the essence of unsupervised learning. It finds hidden patterns or intrinsic structures in input data. A common example is customer segmentation in marketing, where customers are grouped into segments with similar behaviors. Finally, reinforcement learning. Picture training a dog to catch a frisbee. You throw the frisbee, the dog attempts to catch it. If it succeeds, you reward it. If not, you don't. Over time, the dog learns to catch the frisbee more efficiently to get the reward. This is the crux of reinforcement learning. Learning through trial and error to achieve the maximum reward. It's the driving force behind self-learning robots and game-playing AI. In each of these forms, machine learning models are trained on a dataset, then tested on a separate dataset to evaluate their accuracy. This process of training and testing ensures that the models can generalize their learning to new, unseen data. With this understanding, we can now look at the diverse applications of machine learning. Machine learning is not a technology of the future. It's making waves here and now. Indeed, the power of machine learning is pervasive, revolutionizing industries and reshaping our world. Let's delve into some of its most impactful applications. In the healthcare sector, machine learning is a game changer. It's being used to predict patient outcomes, improve diagnoses, and personalize treatment plans. For instance, algorithms trained on vast amounts of patient data can predict the likelihood of disease, enabling early intervention and better patient care. In radiology, machine learning models help doctors spot anomalies in imaging data, making the diagnosis of conditions like cancer more accurate and timely. Now let's turn our lens to the world of finance. Here, machine learning is employed to detect fraudulent transactions, predict market trends, and provide personalized banking services. Financial institutions leverage these models to analyze past transactions and predict fraudulent activity, enhancing security and trust. Simultaneously, trading algorithms trained on historical market data help investors make informed decisions, maximizing their returns. But the reach of machine learning doesn't stop there. It's also steering the wheel in the realm of autonomous vehicles. Self-driving cars use machine learning to interpret sensor data, recognize objects, and make decisions. These vehicles are trained to navigate complex environments and respond to unpredictable situations, bringing us closer to a future where driving is a hands-free experience. Even in our daily lives, machine learning plays a silent but significant role. Every time we ask a virtual assistant a question, it's machine learning that processes our speech and provides a relevant response. When we shop online, recommendation algorithms, powered by machine learning, curate personalized product suggestions, enhancing our shopping experience. Success stories of machine learning are abundant. Google's AlphaGo, a machine learning model, made headlines when it defeated a world champion in the complex board game of Go, a feat previously thought impossible for a machine. In another instance, a machine learning model developed by Carnegie Mellon University outperformed professional human players in multiplayer poker, showcasing the potential of these models in strategic decision-making. These are just a few examples of machine learning in action. Its applications span across sectors, from agriculture to entertainment and from education to space exploration. By sifting through vast amounts of data and extracting insights, machine learning is helping us solve complex problems, make informed decisions, and create innovative solutions. Machine learning is undoubtedly a powerful tool driving progress and innovation. It's transforming our world, making it more efficient, more personalized, and more intelligent. It's helping us unlock the mysteries of our universe, understand the human body, and even predict the future. But like any technology, machine learning isn't without its challenges. As we continue to harness its potential, it's crucial to navigate these challenges responsibly, ensuring that the benefits of machine learning are accessible to all and are used for the greater good. The journey of machine learning is just beginning, and its story is still being written. It's an exciting time to be alive, witnessing the rise of machine learning and being part of its evolution. While machine learning holds enormous potential, it also presents unique challenges. Machine learning, like any powerful tool, isn't without its pitfalls. One significant challenge lies in the potential for biased algorithms. Machines learn from data they're fed. If that data is skewed or biased in any way, the machine will learn and perpetuate these biases. This can lead to unfair and, at times, harmful outcomes. An example of this is facial recognition technology, which has been found to be less accurate for people with darker skin tones. The risk of bias isn't the only ethical concern. As machine learning becomes more prevalent, questions about privacy and data security also rise. We're sharing more data than ever before, empowering algorithms to learn and grow. But how secure is this data? And how can we ensure it's not misused? These questions are still being grappled with. Furthermore, as machines become smarter, concerns around job displacement arise. Automation, powered by machine learning, is expected to replace certain jobs, particularly those involving routine tasks. However, it's essential to remember that while some jobs may be phased out, new ones will emerge. The issues of biased algorithms, data privacy, and job displacement underscore the need for responsible AI development. This means creating algorithms that are transparent, fair, and accountable. It means taking steps to secure data and protect privacy, and it means preparing the workforce for the future, reskilling and upskilling as needed. Fortunately, efforts are underway to address these challenges. Governments, academia, and private companies are working together to establish guidelines and regulations for AI. They're developing ways to de-bias algorithms and secure data. They're exploring how to create a future where AI and humans coexist productively. While overcoming these hurdles is no small feat, it paves the way for an exciting future. Remember, every technological advancement in history has faced challenges. It's through addressing these challenges that we grow, innovate, and unlock the full potential of our creations. For machine learning, the journey is just beginning. As we gaze into the crystal ball, the future of machine learning seems brighter than ever. It's like standing on the edge of a technological precipice, ready to take that exhilarating leap into the unknown. The promise of this digital frontier is truly staggering, and it's all thanks to the relentless march of machine learning. Envision a world where natural language processing has evolved to the point where machines understand us, not just in terms of semantics and syntax, but in the context of our emotions, our subtle nuances, and our cultural idiosyncrasies. Imagine having a conversation with an AI that's so human-like it feels like talking to your best friend. Now shift your gaze to the realm of robotics. The robots of tomorrow won't be mere machines, but intelligent entities capable of learning from their environment, adapting to changes, and even making independent decisions. They'll be our co-workers, our caretakers, even our companions. The line between man and machine will start to blur, and we'll be better for it. But the transformative power of machine learning won't stop at natural language processing and robotics. It's set to revolutionize every aspect of our lives, from how we work and learn, to how we play and interact. It's going to redefine industries, reshape economies, and reorient societies. And yet, amidst this technological euphoria, it's essential to remember that machine learning is not an end in itself, but a means to an end. It's a tool we wield to solve problems, to make our lives easier, to make our world better. It's a brush we use to paint our future, a future that's limited only by our imagination and our ambition. The road to this future won't be easy. There will be challenges. There will be roadblocks. There will be ethical dilemmas. But with every step we take, with every algorithm we train, with every dataset we analyze, we're inching closer to that future. And what a future it promises to be. The future of machine learning is a riveting journey, one we're all a part of.